Question 5 has quite a lot to do in this one. So we've got one point here, the origin. We've got another point here, A, which is 10 minus 23, 10. And we've got another point over here, B, and B is P, 14, and minus 22. So the vector there to there is really obvious, isn't it? It's just 10 minus 23, 10. The vector here to here is really obvious as well. It's P, 14, and minus 22. And the vector here to here. So to get from 10 to P, it's P take away 10. There to there is a long way, isn't it? That's 37. And there to there is minus 32. So there's our vectors to start with. Now I'm going to find out the length of each of these vectors. So we'll do O to A first of all, because that's this one with all the numbers in. So that gives the square root of 279, and the square root of 279, so that one is actually 27. So we know what that one is. But we're going to go O to B as well, and the O to B is this one here. And so we're not going to be able to work this one out because there's going to be some algebra in this. So we've got P squared plus 14 squared and 22 squared, and that makes 680 there. And the other one, we've got A to B, and A to B, they should also have lengths on them, sorry, and A to B is going to be each of these things squared. So P minus 10 all squared, which is P squared minus 20 P plus 100, and the other bits of it as well. So I've got 2493 on the end of that. So what I've just done there while I paused, I said I had 37 squared, 32 squared, and I added the 100. So these are our three lengths, and now we need three different answers. The first answer I'm going to go for is put these two together. So I'm going to do the square root of P squared add 680 equals 27. I'll square both sides. And get a nice answer there that P squared is just going to be 49. And so I've got two values for P there, plus or minus 7 would work for that one. That's if those two were equal. That's OA equal OB. Let's go for OA equals AB next. So that's this one here. I've got 27 equals the square root of P squared minus 20P plus 2493. So if I square both sides again, I get 729 there, and I get all of that. And this quadratic I now get is a 1744 on the end there. Now, if you try and solve that, there's no solutions to that one. You could check that by doing a b squared minus 4ac if you wanted to, but that one's got no solutions. So what that leaves us with one more to do, doesn't it? So I've got to do the OB1 equal the AB1. So let's square both sides before I write it down to save a bit of time. And so the P squareds are then going to cancel out, and I'm going to get 20P equals that, take away that is 1813. And so I've got P is 1813 over 20. The actual question said write down the three possible values for B, and so we know what B is. It's that thing there. Just put the 7 in that, the minus 7 in that, and this thing here in that there.